Imagine assembling a simple linkage, just a pin through a clevis with a snap ring at the end, and suddenly the whole mechanism jams or rattles loose. That tiny mismatch, it's a tolerance problem. Today, we'll test whether GPT and Gemini can correctly determine the required pin dimension and its tolerance for this pivot linkage. And then we'll review how real engineers make sure everything fits just right. By the end of this episode, you will know exactly how to solve a one-dimensional tolerance stack-up situation. So here is the challenge we are running today. Here is our situation. We have a linkage with a clevis, basically two parallel plates with a pin running through them and held with a snap ring at the other side. The thickness of the clevis and ring is known and is given, and the designer wants a small gap so the joint can move freely without wobble. Our job is to determine the pin dimension and its tolerance, so the gap stays within the acceptable limits that the designer has basically specified. This is a textbook tolerance stack-up problem. Small variations from manufacturing adds up and can make or break the assembly. So early in design, we only use nominal dimensions, the about these big values that helps us check stresses and deflections and etc. But eventually, we have to tell the machinist exactly what to make, including allowable variations, and that's where tolerances come in. Now, let's see how ChatGPT solved this problem. We dropped the problem definition and the specification into the GPT interface. That includes the sketch, the dimensions, the given dimensions, and what is missing and what we need. So let's see how GPT goes about this problem. Okay, so gap. So first it defines the parameters, G for gap, C for clevis, S for snap ring, and A for pin. Okay, it's got the dimensions and the tolerances correctly from the picture. That is good. So in the first step, it calculates the nominal value of G, which is the midpoint based on the given minimum and maximum. Okay, that makes sense. Step 2, choose a nominal from the nominal relation. Okay, this is weird. It calculates a nominal, the pin length, based on the geometrical relationship. And yeah, sorry, this is the wrong answer. Let's continue to see worst case, simple worst case stack. So the gap extremes remain inside the allowed band. The total half range affecting G is the sum of half tolerances. Tolerance of clevis, sums tolerance of snap ring, and tolerance of alpha. That is reasonable. It uses tolerances given for all the components properly. To keep G within plus minus 0.584, about G nominal. Basically, it's got the tolerance of G. Okay, so it's got the tolerance right, but the nominal value of the pin wrong. So let's prompt for correction. I put in the prompt that it's got the gap calculation wrong. The gap is the difference between pin length, C, and the ring thickness. So let's see. Still, it is getting the gap equation wrong. So that's why it gets the pin length, nominal length wrong. We have the right answer, and this is not the correct answer for nominal length of pin. But let's, again, I told GPT that the gap equation is still wrong. gap is the difference between pin length and sum of the C and ring. So I had to clarify the geometrical relation. Apparently it couldn't interpret the sketch relation properly, and now it gets it right. So this is the correct relation between the gap and the component's length. If you look at the sketch for the components, assembled components, that's how it should be. Now, if we proceed, it's the same process. It gets the nominal gap midpoint correct. Now it gets the pin length alpha nominal correct. And then it does the worst case stacking. Okay, that's correct. So this is the final answer after twice trying to correct its interpretation of the geometrical relation between components. At the end, the GPT gets the correct answer. Okay. Now let's do the same with Gemini. Okay, so we give the task to Gemini as it was given to GPT. This is the input, the problem definition with the sketch. Let's see how Gemini does the calculation. Okay, worst case situation, best case scenario, and finally it gets it wrong. Yes, problem again is it is not recognizing the physics of assembly, and the gap definition when the parts are gapped. Yeah, we need a more accurate prompt to force it to understand the physics, the situation better. Let's ask for correction here. Okay, now it gets the right answer. That's cool. That was interesting. So now let's break this down as a real engineer would. We know the total width between the clevis plates. We have a desired total gap, and we want the pin length, and also we have the snap ring thickness and then the tolerances. So let's start by defining the critical dimension, which is the gap. We will put a complete step-by-step guide how to solve a stack-up problem like this in one dimension, which explains in more details the exact steps that you must follow to make a loop and to form a gap formula where you start from one side of the gap and then you loop through the whole assembly and put together a table for the tolerance stack up, and then you come to the desired dimension of the critical part, and both for the nominal dimension and for the tolerance of it. But here is the summary. Basically, we have these dimensions. We have 4 dimensions: the gap, the pin, the clevis, and the snap ring. These are the known values, both in nominal and in tolerance. And normally the critical dimension is missing, but in this case, the critical dimension is given with its range. So we need to calculate the nominal value of the gap from the minimum and maximum, and then come also to a tolerance value for the gap. And then we do the math. So on the sum of all these values with their signs, this is important. The signs are very important to get to the right value. So starting from one side of the gap, if it's in the same direction as your gap definition, it's positive. If it's reverse direction, it's negative. So you loop through from point A, you go all the way through the parts and come back, and you aim to get back to the point B. Okay, so in this journey, wherever the movement is in the positive or aligns with the AB direction, it's positive. When it's in the opposite direction of the A to B, then you give it a negative value. The sum of all these values should basically give you the gap in nominal, and also the same for the tolerance. And in this case, because the gap is given, so if gap is the sum of all these 3, then pin is gap minus this minus this. Okay. Also the same for tolerances. And at the end, this is the answer.